Hello, galaxy enthusiasts and stargazers. Today, we're diving into a cosmic event of epic proportions, the beginning of the Andromeda-Milky Way merger. This astronomical phenomenon is not just a space spectacle, but a transformative event with implications for our entire galaxy. Buckle up as we explore what this means for us and the future of our night sky. Imagine two cosmic giants locked in a gravitational dance across the vastness of space. The Andromeda Galaxy, an immense swirl of stars and cosmic dust, is hurtling towards us on a collision course with our own Milky Way. This isn't just a future event set to happen in a few billion years, it's happening right now. For the first time, astronomers have caught these titans not just approaching, but actually exchanging stars. The outer fringes of Andromeda's halo are already mingling with the edges of the Milky Way's halo. Picture this: Andromeda and the Milky Way are the behemoths of the local group, a neighborhood of roughly 80 galaxies. This group is shaped somewhat like a dumbbell, with the Milky Way and its companions on one side, and Andromeda with its satellites on the other. These two clusters are separated by about 3 million light-years and are speeding towards each other at about 123 kilometers per second. That's an astounding 76 miles per second. The impending merger of Andromeda and the Milky Way is not just an ordinary event. It's poised to be one of the most breathtaking spectacles in the history of our galaxy. So, how did astronomers uncover the beginnings of this colossal galaxy collision? And what exactly does this mean for the future of both galaxies? Stars from the Andromeda Galaxy are now drifting into the Milky Way, a monumental milestone in cosmic history. But what might the future hold, especially if humanity is still around to witness the ultimate merger of these two galactic titans? Let's tackle a burning question first. If the universe is constantly expanding, pushing galaxies further apart, why is Andromeda on a crash course with the Milky Way? It all boils down to gravity. Despite the universe's vast expansion, which generally separates galaxies over immense distances, the gravitational pull between the Milky Way and Andromeda is so strong that it overcomes the forces pulling them apart. This gravitational tug-of-war has set them on an inevitable collision path. Cosmic collisions are a spectacle unlike any other, especially compared to collisions on Earth. Consider two cars in a fender bender. This interaction is over in seconds. Similarly, when two asteroids collide in space, they smash into each other at a defined moment. However, when galaxies collide, the process is vastly different and unfolds over millions of years. It's not a sudden crash, but a gradual, majestic dance of stars, gas, and dust, weaving a new cosmic tapestry right before our eyes. Galactic collisions, involving hundreds of billions of stars, unfold as slow and mesmerizing dramas that span hundreds of millions of years. A prime example is the antenna galaxies, named for their striking, antenna-like streams of stars, dust, and gas. These features are the dramatic results of powerful tidal forces at work during their epic collision. Situated about 70 million light-years away in the constellation Corvus, these galaxies have been entwined in their cosmic dance for over 100 million years, offering a breathtaking glimpse into the gradual yet awe-inspiring nature of galactic mergers. Such collisions are pivotal in the evolution of galaxies. The Milky Way itself has been shaped by numerous interactions and mergers across its history. A notable ongoing merger is with the Sagittarius Dwarf Elliptical Galaxy, which is currently being dismantled and assimilated into the Milky Way. This process is not only pulling in streams of stars, but also contributing significantly to the expansion of the Milky Way's halo. Yet, even these significant cosmic events pale in comparison to what lies ahead. The forthcoming collision with the Andromeda Galaxy promises to be the most dramatic event in the future of the Milky Way, reshaping our galactic structure on an unprecedented scale. The first clues that the Milky Way and Andromeda galaxies are already colliding can be traced to an extraordinary type of stars known as hypervelocity stars. These stars are essentially cosmic projectiles, zipping through space fast enough to break free from the gravitational bonds of their home galaxies. Imagine hurling a baseball with such force that it doesn't just arc back to Earth, but instead continues hurtling through the sky, forever lost to the cosmos. That's what hypervelocity stars do, racing away at speeds around 1,000 kilometers per second. To put that into perspective, at such speeds, you could whip around Earth's equator in just over 40 seconds, around 3,000 times faster than the speed of sound in air. But what catapults these stars to such astonishing velocities? Several scenarios could play out, but one primary driver is likely an encounter with a galaxy's supermassive black hole. Picture a binary star system where two stars are gravitationally bound in a harmonious orbit around each other. Now, imagine this celestial duo drifting too close to the supermassive black hole at the center of their galaxy. The overwhelming gravitational pull of the black hole can disrupt their dance, seizing one star and slingshotting the other into the void at unimaginable speeds. The mystery deepens with hypervelocity stars, stellar speedsters ejected from their galaxies at velocities so immense they escape the gravitational bonds of their galactic homes entirely. While some theories suggest these stars are flung from binary systems following the explosive death of a companion star in a supernova, others point to dramatic intergalactic interactions as the cause. Although the concept of hypervelocity stars was first floated by astronomers in the late 20th century, it wasn't until 2005 that the first such star was identified. Remarkably, it's believed that one star gets catapulted from the galactic center every 100,000 years, with around 1,000 of these cosmic sprinters currently racing through our Milky Way. Intriguingly, some of these stars might even originate from the Andromeda galaxy, with an estimated 400 billion stars glittering in the Milky Way. Pinpointing these hypervelocity stars is akin to finding a needle in a colossal cosmic haystack. The task becomes even more Herculean when attempting to identify stars that have voyaged here from neighboring galaxies. To tackle this astronomical challenge, scientists turn to simulations. By analyzing the movements of the Milky Way and Andromeda relative to each other, and incorporating the massive gravitational forces at play, astronomers crafted a model to trace these intergalactic travelers. To unravel the enigmatic journeys of hypervelocity stars, scientists considered not just the visible matter within galaxies, but the elusive dark matter as well. With this comprehensive view, the research team launched simulations that traced the paths of 18 million hypervelocity stars under two distinct scenarios, one where the Milky Way and Andromeda are equally massive, and another where the Milky Way is about half the size of Andromeda. Starting with stars at random positions around Andromeda's core, the team assigned them various trajectories to capture a broad spectrum of possibilities. This meticulous approach ensured the simulations mirrored the complexity of real cosmic movements. As they monitored the speeds of these stars hurtling towards the Milky Way, the researchers made a striking discovery. Although only a small fraction of the hypervelocity stars had the momentum to reach the vicinity of the Milky Way, many retained their initial high speeds across the vast distances of space. Intriguingly, some decelerated enough to be ensnared by the gravitational pull of the Milky Way. By examining a schemap pinpointing the current locations of these stellar sprinters as they near our galaxy, the team could observe their clustering around the galactic center. This visualization not only highlights their incredible journeys, but also sheds light on the dynamic interplay of forces shaping our cosmic neighborhood. In a captivating exploration of cosmic dynamics, scientists delved into how the mass of galaxies influences the capture of hypervelocity stars. They analyzed two scenarios, one where the Milky Way and the originating galaxy possess equal mass, and another where the Milky Way's mass is roughly half. In both models, the stars were distributed almost uniformly across the sky. Yet, the scenario with equal masses revealed a fascinating detail. More hypervelocity stars were ensnared by the Milky Way. This occurs because an equal mass between the two galaxies results in a stronger gravitational pull, enhancing the Milky Way's ability to attract these speedy celestial wanderers compared to when it is less massive. The researchers further aligned their simulation data with actual observations from the Gaia mission, which meticulously maps the positions and paths of stars within our galaxy. This comparison not only demonstrated a remarkable match, but also bolstered the hypothesis that hypervelocity stars from Andromeda are indeed finding their new cosmic address in the Milky Way. The finding suggests that, depending on the assumed masses of the galaxies, the number of Andromedan hypervelocity stars within the Milky Way could vary widely, from as few as 12 to as many as 3,910. Although these numbers represent a small fraction, their presence is a significant indicator of the ongoing intergalactic migration. These findings serve as compelling evidence that the Milky Way and Andromeda are not just approaching each other, but have already started exchanging stellar populations, marking the beginning of their long-anticipated merger. The second clue in our cosmic detective story comes from the halos of the Milky Way and Andromeda galaxies. Imagine a galactic halo as a vast, nearly spherical envelope that wraps around a galaxy, containing both visible stars and invisible elements. Andromeda's halo, a colossal cloud of gases, invisibly stretches far beyond its spiral of stars. If we could see this halo with the naked eye from Earth, it would span 3 times the width of the Big Dipper. Mapping Andromeda's expansive halo presents a formidable challenge, but astronomers have crafted a clever method to tackle it. They use the light from 43 quasars' luminous cores of distant galaxies, energized by black holes situated behind Andromeda. These quasars act like cosmic backlights, illuminating the halo and allowing scientists to explore its different regions. By observing how Andromeda's halo absorbs the light from these quasars, researchers can detect variations across its vast expanse. Leveraging data from the Hubble Space Telescope, the team has discovered that Andromeda's halo extends an astonishing 1.3 million light-years from its center. This remarkable finding not only provides insights into the structure of our neighboring galaxy, but also adds a significant piece to the puzzle of how galaxies interact and merge over cosmic timescales. Imagine a celestial expanse so vast that Andromeda's halo stretches 3 million light-years towards us, and even further, 2 million light-years in other directions. This span is greater than astronomers had previously thought. Considering Andromeda lies about 2.7 million light-years from the Milky Way, this means its halo is nearly reaching halfway to our galaxy. In essence, the halos of these two galactic giants are already brushing against each other, marking the beginning of an epic cosmic collision. The impending Andromeda-Milky Way collision unfolds like a grand cosmic ballet, choreographed by gravity itself. Here's the timeline of this mesmerizing sequence. In roughly 3.75 billion years, Andromeda and the Milky Way won't slam into each other head-on, but will graze past, initiating their first dramatic encounter. This close pass will exert such tremendous gravitational forces that both galaxies will begin to warp and twist, igniting a spectacular burst of new star formation. This breathtaking celestial display will not culminate in a merger just yet. Instead, after this initial brush, the galaxies will recoil from each other, flung apart by their own gravitational energies. But this separation is only temporary, as they will inevitably swing back towards each other for a second encounter. This next approach, starting around 5 billion years from now, sets the stage for a more definitive fusion, eventually merging into a single, united galaxy. In 5 billion years, the Milky Way and Andromeda galaxies will embark on a cosmic dance lasting about 1 billion years. During this period, their cores will come perilously close, leading to dramatic interactions. The supermassive black holes at the centers of both galaxies will eventually spiral towards each other, culminating in a monumental merger. This second approach will trigger even more intense star formation and could eject stars from the newly forming system. By 5.1 billion years, the cores of the Milky Way and Andromeda will appear as a pair of bright lobes in the night sky. The galaxies will continue to pass through each other, losing energy through dynamic friction, which will ultimately cause their cores to merge. As this happens, stars will settle into new orbits within the newly formed galaxy, which will likely take on an elliptical shape, differing from the spiral structures of the original galaxies. By the time this process completes, the solar system could find itself flung to a distant part of the new galaxy or even ejected into intergalactic space. By 7 billion years, the two galaxies will have fully combined to form a massive elliptical galaxy. Imagine the grandeur of these two colossal galaxies colliding, merging, and transforming into something entirely new and extraordinary. This cosmic spectacle is a testament to the dynamic and ever-evolving nature of the universe. Imagine transforming the way you learn, diving into complex ideas with fun and interactivity. That's exactly what Brilliant offers, a revolutionary platform that redefines learning. Instead of just passively absorbing information, Brilliant lets you actively engage with each lesson through hands-on problem solving, proven to be 6 times more effective than traditional videos. Crafted by experts from MIT, Duke, Caltech, and leading tech companies like Microsoft and Google, Brilliant's lessons help you build critical thinking skills that go far beyond mere memorization. You'll gain real knowledge on specific topics while also becoming a better thinker. The best part, Brilliant fits seamlessly into your daily routine. In just a few minutes a day, you can turn moments of idle scrolling into powerful opportunities for growth. Personally, I love Brilliant's scientific thinking course. It takes you on an interactive journey through the physical world, exploring everything from simple machines like gears and pulleys to Einstein's special theory of relativity. Imagine learning by actually engaging with the material, making complex concepts not just understandable, but truly enjoyable. Imagine learning complex concepts by doing fun activities like playing snooker to grasp collision rules, or planning an itinerary for an intergalactic music festival using a space-time diagram. Brilliant brings these intricate ideas to life, making learning interactive and enjoyable. Whether you're just starting out or looking to deepen your understanding, this course is perfect for everyone. First things first, let's break down what we mean by galactic merger. Our Milky Way is currently on a collision course with the Andromeda Galaxy, our closest galactic neighbor. Though it sounds alarming, this process is incredibly slow by human standards and is happening over billions of years. We'll look into the forces at play and why these two galaxies are destined to combine. What evidence do we have that this merger has begun? Astronomers use powerful telescopes to track the movement of Andromeda and have noticed it inching closer each year. We're talking about a galactic approach at about 110 kilometers per second. This segment will cover how scientists use this data to predict the dynamics of the merger. As Andromeda draws nearer, what changes can we expect to see in our night sky? Over the next few billion years, Andromeda will appear larger and brighter from Earth. This part of the video will explore simulations that astrophysicists use to predict the visual changes and the eventual integration of the two galaxies. A galactic merger sounds like a disruptive event, but what does it really mean for Earth and our solar system? Fortunately, the vast distances between stars in both galaxies mean the odds of catastrophic collisions are low. This segment will reassure you about the safety of our planet and explore the potential shifts in our solar system's position within the new galaxy. Finally, let's talk about the long-term cosmic consequences. The merger will give birth to a new, larger galaxy, often referred to as Milkomeda or the Milkdromeda. This union will lead to new star formations and perhaps even changes in gravitational pulls. We'll delve into how this new galaxy might look and operate differently from our current Milky Way. One of the most intriguing aspects of the Andromeda-Milky Way merger involves the role of dark matter. Dark matter, which makes up about 27% of the universe, is invisible but exerts gravitational forces. This mysterious substance plays a crucial role in the dynamics of galaxy mergers. In this segment, we'll explore how dark matter halos of both galaxies interact and influence the merging process. Scientists believe that understanding these interactions could unlock new insights into the nature of dark matter itself. Galactic mergers are fundamental to the evolution of the universe. Through these collisions and combinations, galaxies grow, change shape, and spawn new stars. This segment will take a closer look at the evolutionary journey of galaxies, explaining how the Milky Way and Andromeda themselves are products of past mergers. We'll discuss how the coming merger will contribute to the cosmic life cycle, potentially leading to the formation of new galactic features and structures. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.